Welcome to Computer Vision for Business. Today we have a very special guest. Today we have Timothy Goebel. He's not only a computer vision expert, but he has worked with C-level leaders to demonstrate how computer vision can improve efficiency, safety, and profitability. Let's start with your journey. Can you tell us a bit about your background and how you got into the field of computer vision?
I started off in computer vision in the medical field. I worked in GE Medical on VCTs, CAT scans, MRIs, and stuff like that. And then I left that industry and went into the shredding industry. I didn't get back into computer vision until I started working at Caterpillar and started going on large drag lines and stuff like that, doing recording videos, monitoring people in the area. And then from there, I went into the cheese industry where I really started diving into manufacturing computer vision, AI, or not AI yet, just basic computer vision, where you're doing all the tools it causes it to slower. And I traveled all over the world for it, came up with cut solutions, optimizes the product because you need to hit exact weight. So I started using cameras there. My last camera in the cheese industry was doing scanning shredded cheese and coming up with exact weight in shredded cheese. And then I left that industry and went into the railroad industry, believe it or not. And that was when I first got a taste of computer vision AI. My journey in AI started there because I was able to detect
So,
holes.
sorry to stop you, but when you say computer vision, are we talking about like classical computer vision, like, I don't know, histogram of gradients, this kind of half transform? And when you say deep learning, we are talking about like convolutional neural networks and stuff like that?
That's now. I didn't start doing neural networks until I was in the railroad industry.
All right.
Before that, I was doing the classical computer vision, learning how to use all the tools before even AI computer vision started coming about. And something I knew how to do computer vision and get quality images. I was able to do computer vision in the railroad industry, handling lights and outside the sunlight, and I was able to hit ties for like 14 ties in a minute. Well, they needed 7 ties a minute, and I needed to switch over and start learning AI. So my first way I learned it was YouTube. I learned how to use it off of YouTube. I built my first model from following Sendex off of YouTube, and after I did that, I was like, I need to really study up on this because I was deploying them and getting it running. And I was able to get this machine up and running and doing 8 ties a minute, and stuff was flowing really good. And I was given the opportunity by Foxconn to come on board at Foxconn working on all types of computer vision, AI stuff. I was like, well, great, I'll do that. Went there and I excelled at it and became a senior level AI person for them. Did a medical paper in breast cancer AI, did facial recognition. And then they asked me to do stuff in manufacturing, something I had a manufacturing background, and I was able to detect computer chips on a board, like 3,000 components on a board, and detect each chip and classify them and be able to get the location to the bomb. And that went really well. I just left there because I didn't see me going anywhere, and I went into consulting for a little bit. Went to consulting for a year. Then I wanted to learn more edge computing because that's where stuff was headed. Was able to get an opportunity to work at Lexmark Optra and excelled at doing edge computing stuff. And believe it or not, I was doing projects for them, and I would ask them, "Hey, this company reached out to me. Would you guys mind doing that? Want to do it?" And they would be no. So I ended up doing projects on top of their projects that they would do. We would do their manufacturing, and I also did transportation stuff for them. And outside work, I ended up doing stuff for the NBA, something for the sports industry for fighting, for like gambling fighting, and then other sports. And then I end up doing stuff for what is it for manufacturing again, and this was all while I was working on projects at Optra, but I was doing stuff at night because I was always excelling at it. And then I went and did another project for Department of Transportation out of Nebraska, and really excelled on that one. And then just recently I did I can't go into much detail, but it's called swarm drones, where you have like a bunch of drones that would come up, and that's all I could say. I can't say much more on that one. But so when I was working at Optra, I did stuff in retail, did stuff in the transportation, did some stuff in what is it? Uh, in the oil industry for oil change companies, and
I
there's
see.
other ones. Yeah, so
Yeah,
I've hit everything I feel like I've been in.
that's an impressive resume, and I like to see that we have quite a few similarities. For example, you mentioned that you started with medical imaging, and that was like a big focus of my master. Like that was the first contact I had with computer vision. So it
Yeah.
was also interesting to start at that point, and also learn a bit how you evolve from, let's call it, classical computer vision into the more machine learning and deep learning approach. I feel it was something um, quite natural that I also had to go through, and not to throw shade on classical computer vision, because I feel like in most projects always there's like one or two simple pieces that can benefit from that simpler approach.
Exactly. And when you forget those simple approaches, because when you get new people that are coming into computer vision, they don't know about these simple approaches. They think that you need to use all this high level stuff, but they don't realize that takes up computational algorithms that take up compute power when you could get it down to using just a simple tool. And they're like, whoa. So I actually mentor 8 people around the world on computer vision AI. So
Oh,
I've also been given a book deal to write a book on computer vision AI, also just recently.
that's impressive. Like on a similar note, I actually developed a course, an online course about self-driving cars and computer vision. So I also like also a little bit this teaching side. I think it's something that runs a bit on my family, because both of my parents are teachers. So I always used to teach kids after school. So it was something that I found quite interesting. Right now, I'm not doing it anymore, but now that you're mentioning it, like it was just interesting to see this connection.
I think it's fun. I like it because I hear their challenges that they're coming up with, and it makes me really have to think of ways to how to overcome their pinpoints. And some are so advanced I've never even thought of until they started reaching out to me and asking me. I have one guy that reaches out to me quite a bit. He's from over in Pakistan, but I enjoy talking to him all the time. He has a challenging project, which I'm amazed of it. So,
Great
and
stuff.
his questions are he ends up needing like basic computer vision plus the advanced level all in one. And when he started realizing more of my background, he always started reaching out to me from it.
Interesting. I think there's um, quite a bit of it's not appreciated enough how important is teaching just to master a subject, because you can be great at you can have it in your head, but at the point that you're able to teach someone else is like a complete different level. Like you
Yeah,
need to know it 100% in order to teach it, right?
you need to know it, and then you also need to know when they like make a wrong decision. You need to be able to critique that and explain why it didn't work. And it's even with even companies out there that pick that already start down the journey of a computer vision project, we'll say, and all of a sudden they already spec everything out. People that are just getting into computer vision, they think computer vision is YouTube. You take a YouTube video, use a YouTube video, and that's it. They forget that when you actually do computer vision, you got to spec out all the hardware from the camera to the sensor to the lens to the compute power and all that. And then that's not even done. They forget, oh, yeah, I could do the AI stuff, but then they don't realize, well, you need
What's
to
the
calibrate.
drawback?
Yeah, what about calibrating the camera? You got to calibrate to fix that lens sometime. And they'll forget, they won't even realize that until you start having a conversation with them. And I've known calibrating all the way back from doing the basic computer vision because I had to calibrate the camera to actually do measurements all the way down to the microns. And I was using stuff there, and that's why I was like, you always need to calibrate.
It was very interesting mentioning that you've learned quite a lot of what you know now in YouTube. For me, it has been a very similar journey. Like I feel like there's such a big amount of I think the main drawback of YouTube is that everything is a bit scattered, but when you find a nice series, a nice content creator that you like, it's like
Yeah.
finding a gold mine. I mean, it has been a lot more helpful certain YouTube creators than pretty much
The,
anything that I've ever learned in uni.
the only thing that I would actually say on YouTube is that it doesn't give you everything. You need, if you want to take it to advanced level, you need to have some other knowledge. I could go through books on books that I bought personally just to find one piece of knowledge, and I close up the book and I haven't touched the book. And it's funny because I would have thought, oh, everything's on YouTube. No, it's not all there, but you have to do some other type of
Yeah. To me,
research.
what's missing
Huh?
to me, what's missing on YouTube is that it doesn't push you too much to hands-on experience. Like it's missing that practical experience, which is what makes the difference at the end of the day. What do you think?
Yeah, I agree with that statement because that's what ends up setting me apart. Is I have PhD people reach out to me because I thought about getting my PhD, and people said, "No, don't go do it. You're fine without it." So I've never got it, and they'll reach out to me and be like, "You know so much," and then all of a sudden ask me on stuff, and I'd break it down for them, and they'll be like, "Wow, you actually have real world experience, not theoretical world." So all my stuff that I ever done was full real world use cases. I've never done a theoretical use case. It was actual real world.
Yeah,
So I dealt with all the real world issues of setting it up. The hardest one I could actually say was in the cheese industry. You have stainless steel. Now you have light, and you could have a piece of light, magnify it off one piece, bounce off another piece, shine right into your camera lens, and throw all your measurements off. For 6 months, that one got me. I mean, it got me hard. I would fly all the way to Ireland all the time and troubleshoot this thing. And finally, I just put a big old dome over everything and figured it out. Because once I figured that out, I was able to fly from there all the way to Australia to fix the problem in Australia.
like I feel you're highlighting one of the key issues, not only like with classical computer vision, but especially with the modern deep learning approach, because it's relatively simple to create a data set that's representative of a specific situation. But
Yeah.
when you start adding more and more variables, like what you're saying, illumination, time of day, reflection, stuff like that, if that is not in your data set, that's when you have a problem.
Oh yeah, it's garbage in, garbage out. I mean, all you'll get is why isn't this really working for all these other scenarios, but it's working for this one? And then you get the customer that will be mad and be like, it's not working. Well, look at your data set. Start there, curate that data set, figure out what the environment is before you even start building your model. That's my thing is.
What's normally your approach for curating a data set? Because I feel like this is one of the darkest arts of computer vision,
It
if you
is.
ask me.
I would say it's a dark art, but if you've done it long enough, you know what you need. Like if you're doing outside, your data set outside is different from doing a data set inside. I've done both. And for outside, you have seasonalities, you have light condition, you have weather conditions. You better make sure you have a well balanced data set of all those conditions. And yeah, you create synthetic data. Synthetic data does help a little, but I wouldn't say it helps out drastically because
Mm.
it throws off other issues I've seen.
To
Uh,
me, it has to be like limited to a certain percentage. Let's say
yeah,
something arbitrary, like 10% synthetic data. More than that, you might have problems.
yeah, yes, I agree there. Because I tried creating synthetic data for snow condition, and I've gotten it to work, but it created too much, and I was like, it created another issue. So I just scrapped that idea and just was like, it's better off just getting real world data set because in the snow you got to think about you got snow mounds, you got dirty snow, you got so many issues that come with it, and that was one of the issues that not curating that data set right. Uh, the other one was camera. I mean, curating it for one camera may not work for another camera. So you got to make sure if you're using one style camera and you're running, let's say, 5 cameras. I've done this. Is I have 5 cameras running. 2 of the cameras were a different type of camera. The other 3 were another, and they were at different angles. So people are thinking, oh, you could just grab from the one data set and create data off that. And I was like, you can't. You got to balance all the cameras because you got different angles and different lighting. And once they realized that, they realized this project was not a 3-month project. And that's one thing that it's hard to get through to companies is that computer vision. If you want a quick POC, yeah, you could turn around a quick POC, a proof of concept in 3 months, but to take it to deployment, it's not a 3-month project. It is not even a 6-month project. You'll be close hitting that 6. Sometimes it's a year. It depends on is it outside or is it inside.
I like the point that you are making here about identifying how long a project is going to take. Because, like recently working as a consultant, I feel like what I've gotten on better rather than understanding the model better and all these kind of very advanced deep learning models and so on is trying to find a middle point, something from zero to actually having some sort of setup that can give value to the client as fast as possible. And most important, it can start building the data set. I feel that
Yeah.
now finding that middle point is what is the hardest and what is 90% of the job to probably not so big of a percentage, but you know what I mean. What do you think about that?
I agree. That's why immediately I have pipelines built for is it an edge device, non-edge device, that it will automatically start grabbing data and reduce the time to take for a quick POC proof of concept for them. because usually you have to build that beginning pipeline to get that information start coming. And so I have that pre-built now. So it'll pull any type of camera I plug into it, it works. If it's a USB IP camera or depth sensing camera, it doesn't matter. It'll pull from it. And then I get data immediately. The only difference is I have to understand the lighting environment. That's why it's important for me. It's important for me to go walk where it's actually going to be used at. Because sitting here, like if we're on a camera and we're trying to log in and see the environment, is that camera going to be moved when you log in? And so it's best to always go walk the facility to see it, where it's being used, so you could understand the environment, what are you looking at, and the different conditions that can happen for it. So when you go do a POC, you could eliminate and say, let them know this POC is only going to do this, instead of trying to say it will do everything immediately.
I normally, uh, I feel like it's a 100% requirement to go on premises when it's something about measuring distance, like photometry and stuff like that. If it's something a bit more general, like like maybe just detect people with security cameras or something that's going to be deployed to a lot of different cameras, then I feel like maybe that constraint is reduced a little bit.
It's reduced a little, but you could reduce that by a lot if you went and saw the facility. Because in manufacturing, I just did a manufacturing project that I didn't even walk the facility, didn't even see it, but my friend that asked me to do this set it all up, and I knew he knew some computer vision, and all I had to do is have him turn the camera on and show me the area and help me figure out the distance from the conveyor up so we could get the actual counts and the speed, because we were talking about boards that were flying at like 100 millimeters per second. And we were not using a industrial manufacturing camera. We were using off-the-shelf depth sensing camera to do this. So you got to make sure, is it high enough? Is it low enough? So it was great to have him there that actually helped me out with that, because I was able to have him readjust when it needed to be.
So if not yourself, at least someone that you trust to go on premise. Otherwise, like, yeah, I completely agree with that take.
But most of it, like you said, you could do a lot of it remotely without seeing in the area, but it only reduces a little bit.
I would like us to think now a bit about like the type of visual data that many business rely in order to be processed for many business. So let's imagine. I don't want to put a specific example because, like, I know you've talked about so many industries, and I'm just super curious that when I throw you a question to which industry you lead to.
I actually got one that I don't think people realize it's computer vision. And many companies, not even just manufacturer, healthcare, retail, they all use this, or they could use this. PDFs.
OCR?
OCR, but why is OCR fail?
In PDFs?
That's the key, is figuring out why OCR fails on like a PDF form or on any text, in general. So if you could process PDFs and understand the limitations of OCR, it requires homework for people to go look at the limitations and make sure your code is written to fix those limitations. Detect them.
I see where you're going.
And fix them. If you were able to do that, now you just created a massive ROI return for these companies. I built a pipeline for that already. So I have no problem, and I've done it. So you could actually, like, the biggest problem with PDFs is when someone scans a PDF in and it sends it to you in an email, it's not always perfectly straight. It's skewed. When it's skewed, what happens? OCR reads it, and now OCR has a problem. It'll start bouncing around. Oh, it should be this text, and all this. Well, if you take that OCR and understand the limitations of the DPI, the height, the width of the text, and what it needs to be at, you could correct all your issues on the form immediately. And then once you start understanding that, what I use to know that the word, the text, and all that is correct is something I use for license plate. I take it down to letter evaluation. So I created an algorithm that will calculate, is all the words right per line? And if it's not, you go back through and figure out why didn't it work on that letter? Is that letter and the way the form is need to be added to that data set to train the OCR more? If not, then keep looking and figure that out.
I see. So what you're saying there is that while normally the common pipeline for something that does OCR or optical character recognition for our listeners that they are not so tech savvy, is to first find the text and then perform recognition or try to identify what text has been written. That could be handwritten, just using some sort of font, for example. But normally, if it has some sort of a specific font, it can be retrieved directly. So let's imagine that it's handwritten just to make it more streamlined. So what you're saying, if I understand correctly, is that you added some first step to make sure that the text has been composed correctly, that there is no sort of errors in the display process of PDF, and then based on that, see if you need more training samples or simply need to look farther. Is that in that direction?
It's about correct. The only thing is I do pre-processing of my forms. By pre-processing, I check, is that form square?
Oh,
If the lines start going down on an angle, because I measure every line of the text. And you could do that with basic, and this goes back to our conversation, basic computer vision. Understanding the basic computer vision, if you can understand, okay, that line should be a vertical, you can correct it immediately. So what I do is I check, is all that lines all vertical? And then measure, is the text certain height in DPI or certain pixels. And then if they're all good, what I do is if they're not good, I correct it. So if I even check, is the document upside down, and it'll straighten that document back right immediately. So I do all stuff like that and correct it in the pipeline. And then once it does all that, it automatically goes to the AI OCR stuff and pulls all the information out that it needs.
Is what we were saying, garbage in, garbage out. So if you make sure that what you're sending there is actually something meaningful, then you're just making the life easier, not only for the model, but for yourself, who is the one that has to deal with the failures, right?
Yeah. And, this caught me with the document rotation. That actually caught me in doing medical billing. It caught me. I mean, I did not get it correct at first. And then that's when I realized that my documents weren't straight. So I knew I had to fix them. And then once I fixed that, I was gold.
So now that we are talking about like handling visual data, for example, in the PDF example, which type of companies do you think they can benefit the most from start using computer vision that they are not currently? Like since you work in so many industries, I'm very curious to see what do you think can be achieved that is not done currently.
Man, that is I just written so much stuff out there lately about this stuff because computer vision is hitting every market, everything. I mean, if you think about it, you break it down, it's computer vision. The biggest one I see is oil industry is going to be using it massively. It's coming. If they're not using it now, it's going to be. The secure sector, that one's very popular, but everyone's trying to do gun detection. But the problem is, what's not being done? If you see AI, computer vision stuff being done, it's done right here. What's not being done in between? That's the key to these things, and people don't realize. You want to be innovating, take it to the next level. You need to start looking wider than just, okay, I just detected the object. What are you going to do with that? That's why I started taking it down to, let's use ChatGPT with it,
Yeah.
LLMs, detect it. Now you could tell of a story and be able to send different type of alerts out and be more detailed of the stuff. Um, so trucking industries are using it. But the biggest one I see is medical billing, because they got that No Surprise Act that came through 3 years ago. They have to turn around billing quick. That one's huge. Uh, Retail, I think, is another one, and manufacturing. All three of those, I feel they're not using the OCR to this level yet. But can they be? Yeah, it wouldn't take much.
I think you started like very strong because the two first industries that you mentioned are two active projects that I actually have. So I can see that that you got that pretty much on the point. Like especially for security and surveillance, I feel like this is one of my favorite applications. Just because like it has to be so exhausting to watch at the screen as a security officer
Oh,
for
I,
such a
I
long period of time. Like so like commonly we struggle to watch like 20-second videos with how can you be watching like 9 hours straight to nothing, like nothing happening.
Yeah, nothing happened in the video, and all of a sudden that 9 hours, you're like, did I just see that? When you could have actually had AI on it detect that stuff immediately. Hey, this is happening. Like in casinos, prime example there. I mean, you could use pose estimation and all this other stuff. Even in security stuff, I can't go in much detail of the security one I did, but it was using pose estimation, a bunch of other things that would blow people's minds away. Um, and then,
I like is
yeah,
sorry to interrupt you. I just want to highlight something that you are mentioning because like here, for example, in this one about surveillance, I think we are talking about finding this middle point. Like, for example, if it's some random monitoring application, can be just, is there an emotion? For the one that you're talking, let's leverage pose estimation, and then we'll need to classify. There is always a route that makes the development a lot simpler. And finding it, I feel like that's the most interesting part of the job, at least for me. What do you think?
I agree. I mean, look at the posts I just videos I did in the past about pose estimation. I took pose estimation and started calculating every joint, speed, acceleration, and velocity of every joint movement. Because the reason is now you take that and build a regular classification off of text, what the points of saying this classified, this is what this person's doing, you just opened up a new world.
I mean, like you don't need to train anything per se just to get that information because it's already trained. So it's just about how to leverage that. And uh, I just want to transmit that it's so much easier to work with points, velocities, and this kind of numerical data for a neural network, some classical machine learning, whatever it is that we are talking, compared to an actual image. So this
Yeah,
pose estimation is so powerful for that particular reason.
yeah, because you don't need any of the image data. All you need is the points. That's it. You don't need anything else. And it depends on. And the other key for that is which pose estimation are you using. There is so many out there. I mean, you got MediaPipe, you got PoseNet, you got YOLO V8, V7, Pose estimation. You got to understand which one are you getting into, or in that, and are you going to build your own custom one? So, and the other thing is, are you running on an edge device? If not, or are you running on a GPU? I mean, you got to know all this stuff, and once you do, it changes which one you use.
Yeah, exactly. That right now we've seen it with. It's been more popular lately with LLMs and stuff like that, but distilling information into smaller models is something we have seen with mobile net and other type of smaller object detection networks that can actually run on cell phones. They don't need any particular
Look,
hardware in order to run. You can deploy it anywhere.
right. Ultralytics just released one for MobileNet to run on the mobile. And that's a YOLO model, and that's running on the mobile. And it's like they're just pushing the limits. Now, do we need to develop? I think you can find a model out there and just use it, but you got to train it, but figure out which data you want to use for it.
Exactly. I
I
always feel
remember
like,
the day that I had to train my own VGG 16 for my
and
right.
from scratch. So don't forget from scratch.
Yeah, and then you're doing freezing layers or and all that, and adding layers because you wanted some other stuff. Now you don't even need that, but it's good to understand it because
Exactly.
a lot of times you could still use it.
So what we're saying here is that before it was very common for um, big institutions just to release the structure of their neural networks. So with
Right.
that, if you wanted, you had to train it all from scratch. Right now, it's completely different. Like we have a lot of different models. For example, Team just mentioned YOLO, which is well, some versions are released by Ultralytics, and these ones are already pre-trained in the Coco dataset, which is just a dataset that contains very common classes, let's say person, car, bus, dog, all these kind of very typical ones. And what you can do is just train on top of it. So if we are trying to detect a microphone, what's going to happen? It's going to maybe start to detect some edges that it could understand from some sort of thing like a laptop or something in those lines. So
Yeah.
in summary, training is just a lot simpler. You need smaller data sets and less powerful GPUs because we already have access to pre-trained models.
Exactly. A lot of times you could get away with just training it off of your own computer now. But if you want to go train a brand new model yourself, then build your own neural network. I mean, it's going to take a little bit of time. You got to do your own stuff. There's a lot of formatting of the pipeline. There's a formatting the data structure to come in correctly. Tau Toolkit is a prime example. I mean, you train your own data sets from there, but I would say Tau Toolkit is another good one to use.
Great stuff. So you told us that you have so much projects and so much interesting experience in so many different industries. Can you share some story where you think computer vision has made a massive difference? Like, can be something more complex, something simpler, whatever you like. Maybe one of your favorite stories.
My favorite was my favorite was stacking models on an edge device, and that was pretty recent. It was actually detecting trucks, getting the trucks, the plate, the color, the class, what type of truck it was, and the make, all that information. It was like 8 models stacked on each other and all running on an edge device with 5 cameras.
So
Uh,
when you say stacking, we're talking like gradient boost or like an ensemble?
it's not even ensemble. So what it will do is you detect the truck, and then after that it'll call another model because now you want more detail out of that object that you just
Ah,
detected. And then you grab that information. So that would be a second stage model. So you get that information, but now you got another second stage model to grab more information, and then another one, and then all of a sudden you want to read the plate. So that's a object detection. So that's a second stage plus another stage on top of that to read the plate. So then and then all of a sudden you got the truck ID. So that's another plate like and OCR like that you got to read as well. So doing that, I think that one was eye opening to me because that allowed me to quickly learn how to optimize my models, to learn how to prune models, learn to make them smaller, because this was all running on an edge device. So I had 8 models running on an edge device, 60 frames a second, but getting all this information. So it taught me real quick that there's pipeline leakage that you got to handle. There's data, all that stuff. You got to handle all that. And once you start getting that, you get your basic models all done and you get them stacked right. It boiled down to, well, did you have too much of certain data in that on that pipeline? Because when you go retrain that, do transfer learning, your model's getting bigger and bigger. So a lot of times what ends up happening is that you end up going back through all your data set and figuring out how much data do you need of each area and retrain that model on the new data instead of doing transfer learning on the last model, and keep doing that until you get the model size that you exactly need.
I like the distribution of task, and I feel it's something that we start to see quite a lot now with LLMs. We see like massive models that they can do pretty much anything, and everyone loves them. But we need to understand the trade-offs, right? If you make something so general, like you lose a lot of computational efficiency. You can
Yeah.
make something very small, very niche. So an example that comes to my mind is something like we run a model, we detect a dog. Like then we want to know which breed is that dog. Like then we could run a sequence, a classifier for that particular instance. Was that something in those lines?
Yeah, it was something in those lines, like a dog, what type of dog it was, but breaking down to okay, the color, okay, and then even breaking it down to what type of model, so or type of truck that was. Is it a Mack truck? Is it a Peterbilt? So you get all that information. Well, you know how much data you just pulled out of that image, just having that information of that truck. That data set just became very powerful because now you could use that data and use that for future stuff for the company.
So what was the big highlight for the company? Like when you were selling that to the CTO or whoever was in charge of the project, what was the main selling point from your side to his?
It was the savings that they were saving. I can't go into savings how much it was. It was huge,
Yeah, yeah, yeah. In
and
general.
they made a lot, and that's why it went through. The other one was basketball industry, same thing. If you think about it, the only difference is you got OCR on players' backs and trying to pull all that data out too, and which player is who. So it's the same scenarios. So
Exactly. Like right now
that's
you
what.
can
Yeah,
create
go ahead.
solutions very powerful just by pacing stuff like you're talking about post recognition, post estimation for detecting the players, like OCR to detect the number in their box. And like you haven't had to train pretty much anything, but with that intermediate point is what it allows you to then go the extra mile and get the great results that everyone's looking for.
Yes, and that's where I get people that'll reach out to me and they'll be like, "Whoa, you're thinking way too large." But the problem is when that happens, is a lot of people. Well, I just want to detect this. Well, anyone could build a model and detect something, but what are you going to do different to be different to make it powerful and make it value? There's not a lot of value in detecting a component. I mean, there is, but there isn't. Like in manufacturing, you detect something being assembled. You could detect, is that component on? But now, if you could detect how much is it off, is it skewed? Also, now you just created additional analytics that they could have and be able to go back and fix the root cause of the issues where it'll save them even more money. Is it a vendor issue? Did they put like chips? Did they put that chip on the real crooked? So you could take it all the way back to that batch.
Yeah, like I feel like one of the things that normally people don't understand about computer vision is when you create a project, like it's not only about detection, it doesn't stop there, right?
No,
When you
right?
are able to detect something, you need to give some interesting information about that. Like it could be
Yeah,
about what's the position, like how many are there, are they overlapping, like all this kind of information is there. It's just about how you actually going to extract it in an efficient way or whatever are the constraints of that particular project.
yeah. How are you going to articulate it to the sea level? So, and that's the key is what you're doing here is object detection. You need to articulate that to the sea level to understand the benefit in it. So once you are able to do that, now you just sold it because
I
it
like
sells itself.
I like a lot that we are talking about smart ways to have like a very big, well, return on investment. So I would like us now to think a little bit about small, medium-sized businesses that have a lot of visual tasks. What are the most immediate advantages that you can see by them adopting computer vision? And I'm especially interested in these approaches that we were talking about, like how we can do things in a smart way. What is valuable?
The one that comes to my mind is trucking industry because I know a company that actually they don't do the computer vision part. They're doing check-ins of the trucks and all that. But if you think about it, that truck has to stop at a gate, and then they fill out information, what truck number they are, what color their truck is, the license plate, and that's a small company that's handling that data. Now, if you could incorporate that with their data, now that just made their tool more powerful, more return on investment, and now they could actually start going after larger companies.
I feel it's always about data and how available it is for the client. Because at the point that you have an image, yes, you can interpret it as a human, but in order to extract the information, that's what the computer vision side does. But
Yeah.
when this is done, then you can aggregate it pretty much with anything. It could be like the location of the tracks with GPS, like the status of the
Yep.
vehicles, if there's any sort of, I don't know, imperfection in the wheels or anything like that, but everything aggregated in a single place. So then, if there is some data scientist or whoever is
You could hire
analyzing
a
that,
data scientist to handle that data and take it to another level and start doing additional things where you could actually build a different type of model off that data and do another type of classification for like doing repairs, forecasting repairs or stuff like that. So there's so much other doors that this opens that you got to think bigger than just a computer vision nowadays.
I feel like one good example of that, especially for the tracking industry that we are going on about, would be something like a digital twin, just to fit as much information as possible so that then you can do this predictive maintenance and that reduce number of incidents on the road. That's what everything is about, right?
Yeah,
Minimizing cost,
railroad
maximizing reward.
in the railroad industry, I know a company that's doing this. They're scanning the rail cars as they fly by and being able to detect the flaws and all that with cameras. But you got to remember, those trains are flying at speeds. So they're using like line scanning cameras that come up with images and depth points and that, but able to build that image and do the AI on it and be able to let them know, hey, you got a bolt here or you got some noise here in the railroad industry. Because one, how many accidents do you hear about these railroad cars flying off the tracks because of normal wear and tear that wasn't taken care of in the past? So this system actually detects all that, and they're out of Florida.
Yeah, like a project that I've worked on, it was about quality control, and it was something very similar, not as fast as a train, but effectively we had some sort of device that needed to be evaluated very quickly, and you can see like goes in 2 seconds for images and scans and all this stuff, out, one in, one out, one in, one out. And this kind of very fast automation is what humans would never be able to achieve. Even if you have 8 people looking at the same stuff, I mean,
You wouldn't be able to detect that. With 8 people watching, the stuff moves way too quick. They're like, did I see it? Oh, pause. I got to rewind back.
there's always that point of diminishing returns, right? Like if you have too many people doing a single task, like you're never going to get like linear productivity just
Oh,
by adding more people to the thing.
no, you wouldn't get that at all. That's funny.
That only happens with computer vision and servers, right? If you have that, then you can process double, no questions asked.
Yeah, and the right pipeline too with it,
Yeah.
because is my issue that I just ran into. A company spec'd out their own hardware, and they wanted this camera to run on their system, and I did everything, even reached out to the vendor on the camera, and they were telling me tips, and finally they said, hey, can you check the NIC card? Is that an onboard NIC card, or is that one that's plugged in a PCI slot? And it was plugged in. It wasn't plugged in. It was one on board. That was issue one. It couldn't handle speed. So the next piece was a PoE injector. The PoE injector, they're using a array of a PoE injector that was managed switch of a PoE injector. But
PoE injector is just power over Ethernet, so
yeah,
it's to give power to the camera. I'm just putting some notes for whoever doesn't know it, but yeah, please continue.
yeah, and so when you use something like that, they don't realize that power states that it supplies power not equally to each one, because you could have 3 PoEs plugged in. Now they're sharing that power, so you get the power drop. Well, that camera was supposed to run at 40 frames per second at 4K. Well, 4K, you know, and I know that's a lot of data flying through that, and to get that to run at 40 frames, it's a lot of work. So the power was dropping all the way down to like 12. So there was no way that you were going to get all that bit coming across that in real time at 40 frames. And so the vendor reached out to me and said, yeah, you need to have this change. I was like, I figured that, but I didn't spec that information out. The company I went and worked with, they spec that whole thing out. I had to go to them and tell them they had the wrong specification for their device. Imagine they spent 10 grand on that device and did not spec it out right. So now they had to go get a new NIC card, a new PoE injector, and I told them to make it easier, just buy a PoE injector right to the PCI slot, just put it in, you're fine there. They didn't realize that, so they didn't do it, and the project went. They canceled the project and decided to go another route because of that. And that's one thing that a lot of companies, to this day, forget. If you don't spec out your stuff right, you are not going to hit what you need to hit on the ROIs.
Exactly. And especially like having so many cameras at once, and you mentioned like 4K, 40 frames, that's a lot of data. And when you have that and you have multiple cameras, it's not only like the power, but also how you're going to handle them efficiently. Because yes, modern models can process stuff like even 100, 200 frames a second, but normally this is by reducing the image size to 640 pixels on the longest side. So
I
Like,
tried that. That's a good one because I did reduce the frame down to 640, and I got my frame all the way up to 160 frames a second on that. But when you need to see something at 40 or 50 meters away, your pixels dropped. So you need that 4K because the amount of data you need to see is like 7 pixels to be able to detect, and you wouldn't be able to detect that at 50 meters away. So that's why it needed to be 4K.
that's one of my favorite challenges in computer vision, like trying to detect very small pixels, because you either have to divide the image in crops, like you can use a sliding window, like there's a lot of different options, but it's not as simple as, oh, you can just reduce the image size, because then your object maybe is like 5 pixels by 5 pixels and no one can detect that. Like, I can show you 5 pixels by 5 pixels is nothing.
Yeah, a lot of people think that, but then they don't realize how much data they just lost from reducing that down. And then you're like, you just lost all that data, and and it takes a little bit for them to dawn on them that you just lost this data, and you need that detailed data to take it to the next level.
Very interesting story. So you talk about quite a lot of experience in manufacturing. Is there anything else that you can think of that has had some sort of transformative in the interactions, maybe that the customer have? Maybe it's more for
Yeah,
retail and stuff like that, but anything that has made the the user interaction easier, like they could think a bit like virtual try-ons, behavioral insights, things like that.
there's one that I was asked to work on. It was for blind people.
Oh, interesting.
Yeah, and for you need to check the scenery for them to walk around, and so it tells them what they're seeing. So it's like an interaction with them. And I wouldn't have thought of that, but they needed to understand pose estimation as well to know, is that person running at you or other things.
But how was the
So
interface for that?
it was using glasses and just a mic into their ear.
Ah, really? So
Yeah.
what sort of sentences what were they receiving? Is there something in front of you, or?
Yeah, it'll let you know what's all around you, what you're looking at all around you. So it needed to let you know the scene, everything. It was
Interesting.
something that I was blown away because I'd never thought of that, and
Yeah.
it's a very good use case that people don't. There's so many people that are blind that it would actually help.
One of the things that I normally tell to my clients is like, uh, the best thing about computer vision is that we humans are very good at it. Like, we have evolved over millions of years just to distinguish different shapes. Like, we are stupidly good at distinguishing human faces, and it's an evolutionary trait. So that's why when we see a robot or something like that, we have this sort of uncanny valley effect when they're trying to mimic a human face. And what I mean is this kind of information, extracting information from images. That's what computer vision does. So using it for this particular use case seems like, yeah, pretty much one of the best ones that I could think of. But
Yeah.
yeah,
The
very interesting.
thing is if we look at that, is it opens up so many other doors out there, being able to get this down. And look how long it took us when we were kids. We didn't know what colors were. We didn't know what objects were. That's what you're training models. They're basically a darn kid. That's the way I describe it to everyone that I've ever talked to, is describe computer vision AI to me. Well, basically, you're recognizing what you learned when you're a kid. You're teaching computer vision that.
I mean, that's what supervised learning is, right?
Yeah.
Like, you are telling it, this is an image, this is what you should give me as the result.
Yep.
That's more or less how you teach kids. Not exactly, but to a principle, right?
Hmm. Yeah.
Interesting. Um, So different sectors have different needs. Could you highlight how computer vision is reshaping industries like retail, healthcare, manufacturing you talked about? Uh, which industry you think is going to have the most profound impact by applying computer vision?
Retail is already starting it. It's enhancing inventory management, theft prevention, personal shopping experience. And then the other thing it's handling is being able to optimize the flow of traffic coming into the building for did I put the right kiosk at the right sale for the right area for sales, stuff like that. Healthcare. I just went and talked to healthcare because I'm donating my kidney. So I was at the health place getting checked out, and it's being used in diagnostics, patient monitoring, automating administrative tasks. There's stuff like that happening in healthcare, even optimizing billing. These little small manual processes, I would say. But it's not taking jobs away. People are afraid of that. It's not taking them away. They're making people be upskilled, which isn't bad. The other areas is we've talked on manufacturing. We beat that one down all the time. Quality control, preventive maintenance, automating efficiencies to improve. So there's so many areas that it's being used, and it's just going to keep getting better.
I liked a lot the first point you've made about knowing where to place certain items, because it's something that has been talked about extensively in the website domain, like generating heat maps and understanding all that. And the main difference there, it was that all the data was already available for the websites, but not so much for the retail industry, like the supermarkets, wherever it is that is. And what computer vision does, it effectively giving you the information in a way that can be processed easily. Like you can
Yep.
see where people spend most of the time, and you need to understand, like, is there a reason for that? If it's in the entrance, if it's like maybe in a place where you cannot feel the cold from outside and you just like standing there for a while. This kind
Yeah.
of very interesting information,
And
which
that's huge because one, if you think about it, is being able to detect a person coming into retail and track the trajectory that they're moving and the rate of speed that they're moving at and be able to optimize the direction where they're going. You could put uh, kiosks, end caps where they go to make the sales of the store go up just because of that, just by optimizing placement of your end caps.
and this is one of the simplest things to implement. Like there's countless models that do this stuff for you.
There's so
So
many easy models. You already have pose estimation out there that comes with object detection of the person. So it already has that. Now you just track, okay, well, this camera can only see this much area, and you have a kiosk here, you can track the speed going to that. But now the only difference is you'll have to do re-identification, so it tracks it going to another camera, which is it's not too bad, but it'll keep track. But at least it takes you to the next area, and you can keep tracking all the way through the store.
like all technology is there. It's just about identifying what's the key component for each particular business and understanding that. So that leads me to a question. So if we were to meet someone that has a business and in general they would ask us, uh, what do you think is the first step that I need to do in order to see if my business has a good use case for computer vision and how to identify it?
I would start going down the pipeline of demystifying their problems. Find out their problem statement and go from that. Because being able to understand their problem statement and where they're having problems, you could actually demystify where you could actually use computer vision. is computer vision may not be the first problem. But you could also, and if it becomes the first problem and they think it's big, you got to remember you don't have to take on a huge project with computer vision. You can always break it down to small uh, stages of projects. So the first stage, it'll just detect this, just approve it. And then the next stage, you could start implementing everything else, other pieces to stage 3 and then 4, and add it. Because once you start getting stuff in stages, then you start realizing, oh, what if we add this, and this would bring in this much more ROI. Now you can break that down because you already went through the first stage.
The only thing I would add to what you just said is that we as humans, we are very good at computer vision. I know I already said that, but I think it's a very important point because we can understand what sort of information we can get with our eyes. It's just by scaling that, by having someone constantly looking and being able to extract insights from that, if there's value that you see there, then that's probably a good use case of computer vision. That's how I normally frame
Yeah,
it.
yeah, you're right. Because if you articulate that to the C level, that hey, basically, if you could see it, this is, and no one else could see it besides just you, and when you walk away, no one else seeing it again. That's something to bring up because that shows that'd be a place for ROI. But now the critical piece, how much of return on investment is that? Now you got to break down, is that a good one for them? But you won't know until you hear about the overall picture. They'll be able to hit that full goal.
That's one of the key things as a contractor. That's why I normally like to ask figures to whoever I'm about to start a project with, because like to me, if I have to do, like, I can do my job, but like if this is not going to lead to a specific return for them, like there is no point for me to tackle that. Like, how do you normally handle this kind of thing?
I just went through something similar, that I took on a project that it was supposed to be a year project. And all of a sudden, 3 weeks right before, it turned out to be a 3 week project. After that, even starting it ended up being 1 week. And these are the issues that people don't realize, that you can't, and you need to break these computer vision up in the task. Especially, they didn't realize how big of a task it was, so that's why it became this. And it wasn't their fault, it wasn't mine. It's just something that they didn't realize it. So my thing is be conscious how big the tasks are, and let them know how big they are, so you don't waste their time, waste their money. Because if you waste their time, their money, they're not going to come back to you.
Exactly.
Yeah, I've seen that happen so many times. I've seen companies where a project was spec'd and they would come back to them and it didn't hit ROI, and they would go to the customer, well, isn't some ROI better than none? No, that's a bad comment. It should have never been said, because that means the project wasn't spec'd out right to hit what they needed.
The way that I have in order to mitigate these sort of issues, like when I see a project that is not something obvious, like I like to start always with a roadmap to
Yeah.
identify all the different steps that it would require, and make sure that I have a good understanding of what's the problem as clear as possible, and make sure that I can select what's the technology and how long it's going to take. Because I feel like that's one of the main problems with people that they are just starting with consulting, that they let the client choose the time frame, whereas like I mean, I know it's not your case, I'm just saying it's something that I've seen
I've
quite a
seen
lot.
that too, and that's why I always you need to be in control of the roadmap, to lay out the roadmap, and to be the one to explain in that roadmap why you need to spec out the hardware and everything else. Because without having that, there could be issues in project leak, project drift, model drift, data drifts. I mean, there's all that stuff that if it's not in that roadmap, it'll become an issue where you're going to be losing in the end.
So now that we talked about the way to start a project, I'm curious to hear, like from all your experience, all the different computer vision applications that you've worked on. Is there anyone that jumps to your mind if I say which one has given the company that you work for the biggest competitive advantage, or which one has been the most innovative?
The one that I did that gave, I have a couple that did that. The one I did in the fighting realm gave a ton of advantage. Um, that one was huge.
Can you
That
share a little bit just the general concept of it?
detecting kicks, punches, and that, and being able to gamble on it.
Oh,
Yeah.
I see.
So there's that one, and it was good. Then there was there was a medical one, but it wasn't computer vision that sticks out in my head all the
It's
time.
fine. It's fine. You can share that one if you are in
Uh,
like.
that one was NLP, natural language, but on encrypted data for MRI protocols. That was for the medical industry. MRIs, they use lookup tables to figure out what MRI you need or CT scan you need. This I did with 200 records, 200 different classifications, I would say. And going back to ensembling models, I had to ensemble two models together to build this to get the accuracy they wanted. And I was able to get it up to like 90 or no, about 80, I would say 80. And then what ended up happening is that was on encrypted data. They wanted to test it with unencrypted data. It only dropped like 5%. And they were still happy with it.
No, I mean, like when we are
I was
talking
shocked.
about
I was
big
blown away.
problems.
Yeah, I was blown away because I didn't retrain the model on encrypted data on unencrypted data. I only trained it on encrypted data, and it worked on unencrypted.
That's. I feel like you put before the analogy of the model being like a kid, like a toddler that we are teaching, right?
Yeah,
I always like to think about it in as someone that's very good at finding patterns. Like
yeah,
that's what computer vision is, right? So
yeah,
like if those
yeah,
patterns are encrypted, decrypted, like is encryption going to break those patterns? I don't know. Like if you actually try it, you might be surprised, right? That's
yeah.
the.
I was surprised. I was actually blown away by that because I wasn't expecting. I was like, I'll try it, see what happens, and it
I
did.
wouldn't have expected that in 100 years. Like I wouldn't have guessed that.
I didn't expect it. It worked. So there was that, and then the other one was in the railroad industry. I made this railroad car that repaired the railroad drive autonomously. So at first it was detecting railroad tie spike holes to fill it with epoxy. I was able to get that with computer vision AI, and then after a while, I was like, I bet I could get this thing to drive itself because there was enough sensors on the thing. 2 weeks later, it only took like
That's
less
the
than a
biggest
year.
flex for an engineer, right? Like just
Yeah.
made it do it itself, and and that's it.
So I let it. I was able to get it to drive itself on the track, and when it hits the end of the track and it knew that the rail was there, it would automatically stop and pull up the tracks and get ready to move. I was like, that was a highlight. That one was actually the most highlighted one because that led me into self-driving golf carts because I did self-driving golf carts at Foxconn. That was one of the projects I was working on.
No, very interesting stuff. I actually have quite a lot of experience with autonomous vehicles. I work with autonomous boats, bikes, and cars.
Yeah,
So it was quite interesting to see how they all came together and how Computer vision can be used in so many different ways
Yeah.
for such different environments, right? Like in a
Hmm.
boat, you can pretty
So
much go
many
wherever
different,
you want.
there's so many different industries computer vision can be used in nowadays. It's just what area do you want to specialize in? And that's what when I mentor people, that's one of the questions I'll ask them. Do you know what industry do you want to be in? Because that helps drastically. Me, I've been in so many different industries. I've learned how to take it to each one because I understand the lighting of stuff and once you in the different types of cameras. But for someone just getting off, starting, they need to know what industry they want to start learning and start concentrating on that industry, become a master of that, and then grow your wings.
There's quite a lot of similarities, but if you start with one, you make your life a lot easier.
Uh,
Uh, Now, like, yeah, I feel like
like
being a
you
consultant.
understand, like you understood the basic computer vision before AI started getting in it, and that's where I try getting these people that I mentor to understand these basic tools before you start thinking, oh, I need AI everything. You don't need AI
Exactly.
for everything. It's there's things that you could do without it. There's things that you cannot do without it.
Like, one thing that I always feel about my projects is that when I give the most value to my clients is when I tell them, do not use AI, because like this kind of easier path is the one that actually leads to a simpler solution, which in turn can lead to better results. Like not everything by being more complex is going to yield better results, and I think it's something that's important to understand, and just trying
It gives
stuff
them
is going to
a
teach you that.
when you do that. I bet they're like, "What? Are you serious?" They take a step back, looking at themselves. Are you serious? I don't need to use AI. I could do it without. Yeah, you can.
And I feel like it helps separate yourself from the rest, because I had clients coming back to me like saying like that reminded me specifically about of that fact, like that being like the thing that they remembered the most, which
Yeah,
is, I don't know, quite interesting and unsatisfactory at the same time.
yeah. It makes it easier to talk to clients because they get struck by it, but at first, but then they realize that you're not there to sugarcoat and try to sell them something. You're there to educate them and help them make the best decisions.
So we talk quite a lot about clients, and you have a big LinkedIn account where you talk with quite a lot of people.
Yeah,
One thing that I would like to ask is, when you talk to, it could be like a potential client or someone in LinkedIn that just inquiring stuff, what are the main um, concerns that you see people that they are like the C-level executives that they are thinking about starting AI? What do you think are the main uh, things that they are not quite sure about? Like, is it about the return on investment? Is it about like how well is it going to work? Is it going to differentiate them? What is it?
a lot of times I see a couple areas. One is return on investment. They want to make sure they're getting the return on investment. The other one is they'll see other people posting videos all the time on me and you know there's a lot of car videos out there on LinkedIn. People always using cars or majority of the time. And they'll be like, well, how does that articulate to me? And they want to use that. And all of a sudden, if you have to break it down because on those videos they show stuff being drawn, other stuff being drawn on the image, the real time data being drawn on top of the videos and that. And they don't understand having all that drawn on the video slows down things. And so you a lot of times they'll ask, well, why isn't that on my video? And you have to explain why that is on LinkedIn showing, when theirs don't show that. So you have to explain that because a lot of times they don't have the compute power to even handle that. And there's really no use case of drawing it on the video all the time.
I
So
see what you're saying. So it's about presenting the data to them in a way that's easier to grasp, maybe.
yeah, yeah, where they could grasp it and understand it. Because, like I said, today I saw videos with cars being detected, trails, segmentation, which is all great tools. But when you start adding all that segmentation, you have hundreds of cars on the screen. That slows down the compute power of what's being done because you're drawing on top of the video at the same time as it trying to process. When you do that, it slows down the processing, so your frame rate drops. Well, you could actually kick that information to a CSV file so they could do spreadsheets, or if they want to do charts and all that. You don't have to, and then they could see it there what's happening. But it all depends what you're really trying to do, and that's where customers will ask these questions at because they would like to see it, but didn't understand why it's not there.
I see. So there's like this particular gap in terms to explain um, what's the best way to represent the data. Like for them, it could be like in any particular form. It could be a CSV, it could be drawn on top of the video, and
Yeah,
then make sure that they understand the different trade-offs of one and another.
yeah, and you have to break that down to them to let them know upfront when in the roadmap. You'd actually let them know in the roadmap. But yeah, that's the only ones that I see so far that I've ran across.
Yeah, no, interesting. Um, you mentioned that you had some projects in the medical imaging field.
Mhm.
That particular industry is heavily regulated, and there's quite a lot of data privacy and security concerns
Mhm.
for businesses that handle this type of data. I mean, of course, it's something that benefits all of us. But what sort of procedures, what sort of things do you normally do in order to ensure that all your, not only medical imaging, but more security oriented and all the projects
HIPAA,
that
you gotta
require,
you
yeah, go
gotta
ahead.
abide by the HIPAA law. Make sure everything in that pipeline is controlled by with HIPAA standards and
Could you explain
remove.
a bit that more for our non-technical users, please?
Yeah, it removes all the metadata out of the image that would say who the person is in that image or that. And sometimes you wouldn't know that it's there. You'll find a model that's pre-built. I've seen this myself. And the only way to really know is you have to extract that data out of that model. So you got to do reverse engineering to take the model that was built to create the images that was in that model. So like TF records, you could
Yes.
take the TF records and extract that data to images.
TF records is just a format, binary format to store
Yep,
data to train. It's for
that's
transmitting.
all it is. And what I found when I did that, because I had issues in the model for breast cancer AI, and it had the X-ray text tag number and tags all in it. And then some of them were saying that breast cancer, and some of them said not. So I knew the data set was garbage. So I had to. The only way to know that was I had to extract it and create it. So the one thing my tip for this is for the medical industry is not only abiding by HIPAA, you always need someone that is a specialist in that area. So if you're doing cancer detection, make sure that you're working with a doctor to curate that data set because you don't know what you're detecting. You could build an object detector and it may be working, and all of a sudden you may have called it something else that it's not benign or something else or malignant or whatever, and it was wrong. So you don't want to get stuck in that because there's so much regulation in AI and medical where you need to document every line. There's certifications that you got to have for your product and all that, and which costs millions. So make sure that you're working with the medical team, and that I've worked with a medical college, and they actually have all the data from the hospital in servers that are curated already.
Mm.
So that's what helped me because I didn't have to do that. It was already there. They gave me the data set already curated to the type of breast cancers it was. And there was like
Perfect.
7 different classes. So people, all I see usually people doing benign, malignant. Realistically, there's 7. There was 7. And then like for I've seen one just recently, brain cancer detection. And I saw the person show it on LinkedIn, say, look, I'm doing brain cancer detection. Check this out. And I go, and he goes, see, it's detecting and it's cancer. I'm like, how do you know that? Do you have the ground truth of it? So you could, if you showed the ground truth plus the detection, now you could actually say it. Because the ground truth, find out if there was a doctor that labeled that data set. Because now you have something to go back by. Now, if it wasn't, now you're speculating. That's why it gets there's so much a gray area when you see that on LinkedIn and people saying they're doing medical vision AI and they don't have the background for it.
One of the biggest problems with medical imaging, in my perspective, is that it's the most expensive thing to label ever because it needs to be done by experienced doctors, and they really do not want to be labeling that stuff. Like, I mean, it's just fair. Like, I don't think I would be
Oh, the other
labeling that
is,
stuff
well, they
if I
have a
was a
team.
doctor.
The thing is, they do have teams in the hospitals that do computer vision AI now. But they still need the doctor to label it, and especially if you look at the MRIs, they have new things out there. You can draw boxes as it actually scans and sees stuff. And doctor can just draw a box immediately. But now, what if they want to do segmentation? Now
That's
that
a
the segmentation and draw that dots. I mean, that's on a little. That's huge. It's on any project. Segmentation just hate to say it, it sucks. The label. There's no better way to put it. If I know I'm doing a segmentation job, that's there's a trade-off in the pricing.
good stuff. So we talk about quite a lot about the different steps of a medical imaging process. So could you demystify a little bit what are the different steps? Doesn't need to be about medical imaging, can be in general. And just to explain it in such a way that shows the value of each of those to a CTO or anyone in the C level, like how would you sell each of the particular steps to them and explain it? Like for example, if you have to build more of a data set, what are the advantage that you're going to get from that
Oh
versus
yeah. Using pre-CAN based data set like that, right?
yes, exactly.
Yeah. So I break it down to C levels always that there's steps that you got to take to building your pipelines. The first one is uh, creating a data set. And they would ask, well, isn't there a data set out there that would get us further? Well, sometimes there's not. And then there's sometimes that you have to pay a licensing fee for the data set. And I would let them know what that is and break that down. And then they would ask me, well, how are we going to get this data set? And I explained to them that as we're setting up the hardware, specking all this out, you're already going to have it and start being able to pull the data and to start curating the data set. From there, I would let them know that we need to curate it by extracting the data because most times it's as videos. So you got to extract the videos to images to create the data that you need. And once we, and from there, but at the very beginning, we'll also talk about how many classes are we detecting, what are we detecting, so we know that when we start labeling the data set, because now you got to label it. And so I break all that down in a roadmap, letting them know, and then getting to the pipeline, what it's going to take to train it, and then after training, let them know how the testing goes of the pipeline and the data, because you don't want to train that data. You don't want the same data set used for testing. You want to make sure it's split and never seen your data for that model. And then from there, what I end up doing is I end up letting them know that it's an upsell in ways, is let them know about ML ops and break down ML ops for them. Because we're already going through this pipeline, and eventually let them know if they want to update these models, it would be good to eventually have ML ops. So you're actually upselling them to the next phase of future. Then you break down why that is needed, because of data drift, model drift, and that. And by letting them know, you just took them all the way through the roadmap of what it's going to take to get them to their product or a proof of concept. And that's the high level of what I've done.
Very, uh, very interesting stuff. So the only point that I have, so like starting from the very beginning, we need to build the data set, and this could be either we build it ourselves, we find it online, or we have to pay for it.
Mm-hmm.
Then after that, we need to train the model, evaluate it, make sure that everything is ready, and then we have the final deployment, also called MLOps, just to say that we can quickly train a new model and deploy it and make sure that everything is working as expected. And I feel like those are the main components.
Yeah, the
Perfect.
only other thing that I would add in there is, once this is built, is to have data governance in the very beginning. And that lets them know, you break down data governance and why you need it to secure it. And
Can you explain a bit more data governance?
it's the security of the data, and also being able to understand what's going into the model, so and how it's managed. So if you have this, so you're handling the security of the data coming in, and then you're also handling how the data is broken down, and you're doing the revving of the data sets right there for the data governance, and also labeling. So and all that is secured so it doesn't get out. That's a high level of data governance.
Perfect. Yeah, clearly the security of the data and making sure that the pipeline is secure from beginning to end is quite important process. So it's good that you highlighted that. So
There's
let's go with the, yeah, go
one
on, sorry.
other thing I would add in there, is that explainable AI is very helpful
Oh,
for,
yes, yes,
like,
indeed.
if it's starting to make wrong predictions, very good tool to have in there is explainable AI, so you could understand what's going on in the model and the data and that.
So one example of explainable AI is, let's say, let's imagine we have a classification system, we could use one of those explainability systems in order to understand which part of the image has been used in order to classify that as a dog or whatever it is.
Yeah, and
Um,
if it made the wrong classification, you'd actually be able to see and understand why it did that, and be able to correct the issue.
so for object detection, is there such a system that you are aware of?
There is such a system for an object detection, and it's with using the heat map stuff that will show you why it came up with the detection. And there's other tools out there that actually, I gotta look it up, but there's a tool out there that will tell you why it made the detection. It's a plug-in into Python that does it, and you just implement it into the tool.
I wasn't aware of that. I saw some post that they were talking about that you could see the intermediate features, like kind of the different layers of the convolutional neural network inside.
Mhm.
So that normally it's explained as a description of the different features. The classical example is for the face, we have the eyes, the nose, the ears,
Yeah,
and the mouth. Um, so that's interesting to learn about those. Thanks for bringing them up. I will actually have a look because I wasn't aware of those.
yeah. I used a couple in my last place I was working at. I used a couple, and it was very helpful.
Interesting. All right, so let's go with the final question. We talk about quite a lot of different parts of computer vision. Let's talk now about the future. How do you see computer vision evolving, and where do you think this is leading to?
Man, it's computer vision is evolving so much now. Look, I mean, you have humanoids that's using computer vision. You have other robots using computer vision now for outside, and you have robots detecting people for intruders and stuff. So, and then doing it. A lot of it's going to robots. I hate to be honest with you, is I see robot industry increasing drastically, um, hands over fist, because it's not just using the computer vision; it's using IoT, it's using everything from it, and it's all in one system. So I think that's going to be huge, and it's going to be medical is going to be huge for it. I just saw something crazy recently. I was like, no way, but I can't even. It's what was a head transplant? I was like, are you kidding? And
What
it
was
showed,
that?
and there's a paper out on it and everything. I was like, this is it doesn't it blows my mind because we already done face plant transplants and they work uh, the way they described it with the robots and everything, and it blows my mind where things are headed. That's why, like today, back. I mean, if you think about back in the day, we watched Back to the Future with flying skateboards and all that. You
Yeah.
know, we all thought, oh yeah, I want a flying skateboard. Now, look, you got flying freaking jets, planes that fly like that quadcopters that you can sit in called
Ah,
Jetson.
yeah.
And I mean that's like the cartoon Jetson. So that's why I'm like it doesn't it blows my mind because the sky now is the limit. I can't say something's not going to be done because there is so many ways to leverage computer vision, especially with stacking, having multiple stages of models incorporated to make it more powerful to understand stuff. I mean, it's the sky's the limit. It's going to be in many areas.
So heavy emphasis on robotics and agents. Very interesting topics. Do you think that the LLM with multimodality is going to be like the end all be all for computer vision, or you think there's always going to be a place for pure computer vision models?
I think there'll still be a place for computer vision models. Uh, the LLM modeling of computer vision, to build those models, that's expensive. That ain't cheap. So that's why I'm like, until they bring down the cost of that and figure out a way to make them smaller, I think computer vision it'll always be used in our traditional AI models, CNNs, and that.
Exactly.
And then
And
they'll just leverage it in an LLM if they want to do additional um, storytelling off of what it detected.
I feel it's going to be something like you mentioned, with a special emphasis with the agents. You can have the LLM with a bit of multimodality to
Mhm.
orchestrate everything and then tell, all right, what have you detected here? Uh, Now we can have those very specialized models. We talk about detecting the breed of the dog. We talked about detecting the color of this particular clothing item or whatever it is,
Yep.
and try to get the right tool for the right problem to scale.
Yes. Yeah.
Perfect. So that has been all. Thank you very much, Timothy, for your time. And we hope to have you here another time in the future. So thank you very much.
Yeah, definitely. This was a great time. I appreciate it. Enjoyed it.
Perfect.